Let's look at section 10.3, solving equations by making U substitutions. In example 1, we have x to the fourth minus 13x squared plus 36 equals 0. Now the problem here is the power of 4. We have never solved a problem with a power of 4, but we know how to do quadratics if it has a power of 2 in the exponent. We can do this. So that's what we're going to do. We're going to try to change this into a quadratic, a power of 2. So I'm going to just rewrite this. What should I square so I get x to the fourth back? Inside of the parentheses would have to be x squared. If we square x squared, it gives us x to the fourth. And so I could rewrite my equation now as x squared squared minus 13x squared plus 36 equals to 0. And if I were to replace both of these x squareds and do a U substitution, we can rewrite it as a power of 2. So let's do that. If I let x squared be my U, this is going to rewrite the equation as this. We're going to have U squared, because it's x squared being replaced by the letter U. So it's U squared minus 13U plus 36 equals 0. And this x squared again is replaced by the letter U. Since this is a power of 2, I can try to do factoring now. So let's try to factor this. We'll use the diamond method. Let's draw ourselves an x. We'll put the 36 on top and the negative 13 on the bottom. What two numbers multiplies to get 36 but add up to get negative 13? And those two numbers are negative 4 and negative 9. So this can be rewritten and factored as u minus 4 times u minus 9 is equal to 0. What does this mean? Well, we can solve for u. I could say u equals positive 4, or setting this equal to 0, u minus 9 equals 0, we can say u is equal to positive 9. But we don't want to solve for the letter u, we want to solve for x. So we'll replace the u with what it is equal to, which is x squared. So let's let x squared be equal to 4. And on this side we have x squared equals to 9. We can solve for x by taking the square root of both sides, but don't forget we need a plus or minus symbol here in front of the square root. We need a plus or minus symbol in front of the square root. So this simplifies now as x equals plus or minus the square root of 4 is 2. And over here we have the square root of 9 is going to give me a 3. So this is plus or minus 3. We have 4 solutions: negative 2, positive 2, negative 3, and positive 3. So the first step is to do a U substitution. So it's a power of 2, and then we could factor it. And then at the end, make sure you undo the substitution, replace that U with the original value, which is x squared. Let's try it again. Let's try question number 2. What should we make our u? Well, I want to rewrite it as a power of 2 again. So what goes inside so that we don't change anything? Well, that's x squared. X squared squared gives us x to the fourth. So I'm going to let my u be x squared. This means these x squareds will be replaced with the letter u. So we have u squared minus u minus 12 is equal to 0. And since this is a quadratic, we can try to factor it. Let's put negative 12 on top, negative 1 on the bottom. What do numbers work? We have a 3 and a 4, but this has to be a negative 4. So this factors as u plus 3 times u minus 4 equals 0. Since we have two numbers that multiply to get 0, I can set each of these factors equal to 0 and solve for the letter u. So the first one is u equals negative 3. And for the second one, we have u equals positive 4. What was u originally? Well, u was x squared, so we'll replace that with an x squared equals a negative 3. And this would be x squared equals a positive 4. We have to take the square root of both sides now. So let's take the square root of this side, square root of that side. We could do the same thing for the other equation as well. Don't forget that plus or minus in front of the radical. So this simplifies to x equals plus or minus. Now we have a negative on the inside, so we'll pull out the I. This is I root 3. So that's two solutions, negative I root 3 and positive I root 3. For the other side, we have x equals plus or minus. The square root of 4 is 2, so we have another two solutions here. Note, when squaring both sides of the equation, we need to check for extraneous solutions. We need to check for extraneous solutions when squaring both sides of an equation. In this example, it's more difficult to find what u is supposed to be. So I'm going to rewrite it just like I did before. And I want to make a guess. What should I square so that I get x from squaring that? Think about it for a moment, and you should guess it's the square root of x. If I square the square root of x, what happens? Well, that's going to cancel out that radical, and that gives me just x. So the square root of x squared is x, and that's what I want. I want to rewrite this so it's still equal to the original equation, and that tells me what my u is. The u is going to be the square root of x, and that's going to transform our equation into something that we can factor. Let's rewrite this as u squared minus, or it's actually plus 3 times the square root of x, which I will replace with a u again. So it's u squared plus 3u minus 10 equals 0. Let's see if this factors. We have negative 10, 3 on the bottom, and so the two numbers are 2 and 5. Let's say negative 2 and a positive 5. So this factors as u minus 2 times u plus 5 equals 0. And so I could rewrite this or solve for u equals a positive 2, or u equals a negative 5. But remember, u was originally the square root of x. So let's replace the u with the square root of x again to solve for x. And so we'll do it to both sides of the equation. The square root of x is equal to 2, and the square root of x equals negative 5. How do we get rid of the square root of x? Well, we'll have to square both sides of the equation, and we'll do it to both sides of this equation. This simplifies to x equals 4 as the first potential solution. And on the other side, we have x equals 25 as our second potential solution. The reason I use the phrase potential is because we have to check our work to make sure that this is a good solution. So let's check x equals 4 first. We'll plug it into the original equation to make sure it works. So we'll do 4 plus, we'll substitute it into the equation. We have 4 plus 3 root 4 minus 10. Is that equal to 0? This is 4 plus 3. The square root of 4 is 2. Minus 10. Is that 0? We have 4 plus 6 minus 10 equals 0. Yes, that's true. So that tells me x equals 4 is a good solution. This works. If you do the same thing with 25, we'll substitute a 25 into the original equation. We'll check to see if this is true. We have 25 plus 3 times the square root of 25 is 3 times 5 minus 10. Well, that's not going to be equal to 0. On the left side, you have 25 plus 15 minus 10. That's clearly not equal to 0. So 25 doesn't work. It's an extraneous solution, but we only got that right because we checked our work. So don't forget to check your work when you're squaring both sides of an equation. In example 4, again, I want to rewrite it so it's a power of 2, and hopefully you can guess this one. What should I square to get a 2/3 back? This is what we want to end up with. So what needs to be inside the exponent? Well, if you're going to have a 2 squaring something, you're going to actually multiply. So if you think about it, 1/3 times 2 is 2/3. That's our u. We're going to have an x to the 1/3 on the inside. And a tip for you is to look at the middle term. That typically is what our u substitution is going to be. So let's let x be equal to the 1/3, or u be equal to x to the 1/3. That's our substitution. So let's do that. Let's replace all of those x to the 1/3 with the letter u. So this is u squared minus 4u plus 3 equals 0. And now we can try to factor it if possible. And the two numbers are a 1 and a 3. They're both negative. So this factors as u minus 1 times u minus 3 equals 0. If you set each of these factors equal to 0, you will get u equals a positive 1 or u equals a positive 3. But u was originally x to the 1/3, so I can replace this back with an x to the 1/3 equals 1, or x to the 1/3 equals 3. Now, how do we get rid of that 1/3 in the exponent? Well, if you remember, x to the 1 over n is equal to the nth root of x. So we can actually rewrite this as a radical. Let's rewrite it as a radical. This is equivalent to the cube root of x equals 1, and the cube root of x equals 3. And if you remember, to get rid of the cube root, you use the opposite. You raise it to the exponent. So let's raise both sides to a power of 3. This simplifies as x equals 1 cubed. That gives me 1. So that's our first solution. And for the second solution, we have 3 cubed, which gives us 27. Now, do I have to check my work? Well, we raise both sides to an odd power, so you don't have to check your work. But you could, just to make sure that these are two good solutions. But in this case, there's no issues. We won't have any extraneous solutions. Example 5, again, we'll have to make a guess what our u is going to be. And as I said earlier, the tip is to look at the middle term. If you put an x to the 1/2 inside here, 1/2 squared does give you just x. So that matches with the original equation. So I'm going to let x to the 1/2 be my letter u. So this translates into u squared minus 6u plus 5 equals 0. And again, we'll use the diamond method to factor this. I got the two numbers are -5 and -1. So it factors as u minus 5 times u minus 1 equals 0. And so if you solve each of these factors, set them equal to 0, you would get u equals 5 or u equals a positive 1. Now, what was u originally? Well, it was originally x to the 1/2, so let's convert that back to x to the 1/2. If you remember from the previous problem, we could write this as a radical. So this is the square root of x equals 5, and the square root of x equals 1. How do we get rid of the square root? Well, we'll do the opposite. We'll square both sides of the equation. And so on the left here, we get x equals 5 squared, which is 25, and x equals a positive 1 on the right. Now you can't accept these as good solutions. You gotta check your work because we squared both sides. So I gotta check my work to make sure it's a good solution. Let's try 25 first. And when we do this, we will plug it into the original equation. So we have 25 minus 6 times 25 raised to the 1/2 plus 5 equals 0. This is 25 minus 6, and 25 to the 1/2, that's the same thing as the square root of 25 plus 5 equals 0. So this is 25 minus, I know the square root of 25 is 5, so 5 times negative 6 gives me negative 30. And so this does work. It does give us a 0. So x equals 25 is a good solution. And similarly, if you were to substitute a 1 into the equation of the original problem, you would get 1 minus 1 to the 1/2, that's just 1. So we get 1 minus 6 plus 5, and that's equal to 0. So these two are good solutions. In example 6, what is our u? Well, it's going to be this x squared minus 4x. So let's let u be equal to x squared minus 4x. It's going to be a complicated u substitution, but it will work out. So if I replace all of the x squareds minus 4x with the letter u, I would get u squared minus 9u minus 36 is equal to 0. If now using the diamond method, let's factor this. This gives me 12 and 3. It has to be a negative 12 to work. So this factors as u minus 12 times u plus 3 equals 0. Setting each of these factors equal to 0, you can see that u must be equal to 12, or u is equal to negative 3. But our u was originally x squared minus 4x. So I'm going to replace the u with x squared minus 4x equals to 12. And then x squared minus 4x equals to negative 3. Wow, this is an interesting problem because we have another quadratic. So we'll set each of these equal to 0. For the first one, I'll subtract 12 to both sides. For the second one, we'll add 3 to both sides just to set our equation equal to 0. And you'll see this is x squared minus 4x minus 12 equals to 0. And on this side, we have x squared minus 4x plus 3 equals 0. What do you know? We got to factor this thing twice. So let's look at the numbers. Let's try to factor this. And so the first number here would be 6 and 2. We have a negative 6. That will work. And on this side, we can factor it with a 1 and a 3. They both have to be negative. So this equation right here factors as x minus 6 times x plus 2 equals 0. On this side, we have a factorization of x minus 1. x minus 3 equals to 0. So we have 4 solutions. If you set each of these factors equal to 0, I would get x equals 6 or x equals negative 2. That's the first 2 solutions. And for this one, if you set each of these factors equal to 0, you would get x equals 1 or x equals 3. So we got 4 solutions here. 1, negative 2, 3, and positive 6. So 6 is a solution, negative 2 is a solution, 1 is a solution, and 3 is a solution. Do we have to check our work? Well, we did not square both sides at any moment, so we don't have to check our work. So that's good for us. In example 7, we're going to solve this radical equation. We're going to have to isolate that radical, get that radical by itself. So let's add 7 to both sides. This gives me x plus 7 equals the square root of x plus 9. And you know what to do now. We're going to raise both sides to a power of 2. That means on the left I have to FOIL this out. On the right, well, that's just x plus 9. That cancels out that square root for us. And on the left, we'll have to FOIL. So let's FOIL this out like so. So we should get x squared plus 7x plus another 7x plus 49 equals x plus 9. I'll collect like terms. So this simplifies as x squared plus 14x plus 49 equals x plus 9. We'll subtract x to both sides, and we'll also subtract 9 to both sides. So we could set it equal to 0. And so this gives me x squared plus 13x plus 40 equals to 0. So now we could try to factor this. Let's put the 40 on top, the 13 on the bottom. What two numbers multiplies to get 40 but add up to 13? And so the two numbers are 8 and 5. So this factors as x plus 8 times x plus 5 is equal to 0. And if you solve each one of these separately, you would get x equals negative 8 or x equals negative 5. Now, we square both sides of the equation, so you have to check your work. You have to check it in the original equation. So I'm going to check here. We'll start with the negative 8 into the original equation. So negative 8 equals negative 7 plus the square root of negative 8 plus 9. This simplifies to negative 8 equals negative 7 plus the square root of 1. And so you can see that this is not true. The square root of 1 is 1, and this is a false statement. So negative 8 doesn't work. It's not a good solution. We'll check negative 5 to see if that works. And we'll substitute it into the original equation. And so we have negative 5 equals negative 7 plus the square root of 4, which is 2. So this does work. It's true. And so negative 5 is a good answer, but negative 8 wasn't. Again, you have to be careful. We have to check our work because of that extraneous solution when we square both sides. Example 8. Again, I want to isolate that radical, so let's subtract that 5 to both sides. And we have now x minus 5 on the right, and on the left is the square root of x plus 7. Let's square both sides, get rid of the radical. That's what we want to do. We'll square both sides to get rid of the radical. So this gives me an x plus 7 on the left, and on the right we're going to have to FOIL. The radical cancel out on the left, but on the right we're forced to FOIL. After we FOIL, we should get the following. x squared minus 5x minus 5x plus 25, and that's from foiling. Let's subtract x to both sides. Let's collect like terms. So this is going to give me x squared minus 10x plus 25 on the right. And then we'll subtract x to both sides. And we'll also subtract 7 to both sides. This gives you 0 equals x squared minus 11x. And 25 minus 7 is going to give us a positive 18. So now we could try to factor this if possible. We have 18 on the top, negative 11 on the bottom. So that's 2 and 9. And that means they're both negative. So it factors as the following: x minus 2, x minus 9. If you solve each one of these separately, set it equal to 0, you get x equals 2 or x equals a positive 9. But we have to check our work because we squared both sides. So I gotta check my work to make sure this is a good solution. We'll check x equals 2, and we'll do that in the original equation. So we'll replace all of these x's with a 2. So I'm gonna write the square root of 2 plus 7 on the left plus 5, is that equal to 2? So we have 2 plus 7, that's the square root of 9, plus 5, is that equal to 2? The square root of 9 is 3. 3 plus 5 is not equal to 2. So 2 doesn't work. 2 is not a good solution. It is an extraneous solution. If you check x equals 9, you will realize it does work. So check that on your own. Do that work on your own. It does work. X equals 9 is a good solution. When solving rational equations, we need to omit solutions that produce a 0 in the denominator. So if your solution causes the denominator to be 0, that doesn't work. It'll be undefined at that point. So always check for solutions that would result in a 0 denominator and throw those out. So let's look at this problem here. I am going to start by factoring the denominators. If you look, the denominator on the right here can be factored as x minus 4 times x plus 3. And that gives me a chance to find the LCD. The LCD is all of the denominators together. So we have an x plus 3 and an x minus 4. I need to be divisible by x minus 4, so that's why I took that. I need to be divisible by an x plus 3, and so we have that. And the second, or the denominator on the far right here, has both components, and that's all we need. We don't need any additional factors. We don't need any additional factors. And so we're going to multiply now the LCD, x plus 3, x minus 4, times the first term. And that first term is x over x minus 4. Then we're going to use the LCD again. This is x plus 3, x minus 4 times the second term now. And so that's multiplied with 2 over x plus 3. This is equal to the LCD again, which is x plus 3, x minus 4 times the last term, which is this big fraction here. So we have 6 divided by x minus 4, x plus 3. Now the fun part, we can see that x minus 4 divides out with x minus 4. X plus 3 divides out with that x plus 3. And on the right here we have all of these disappearing, which is exactly what we want. And so now we have x plus 3 times x left over. And here we have x minus 4 times 2 left over. and that's equal to 6. This is good because now we can distribute and simplify this. So this is x squared plus 3x plus 2x minus 8 equals 6. Let's collect like terms. X squared plus 5x minus 8 equals 6. Then we could subtract 6 to both sides of the expression. And so this gives me x squared plus 5x minus 14 equals 0. Now let's see if you can factor this. Negative 14 on top and 5 on the bottom. It must be a negative 2, positive 7. So this factors as x minus 2 and an x plus 7 equals to 0. So we have two possible solutions. X could be equal to 2 or x could be equal to negative 7. It's possible that they both could work. So we'll have to check our denominators. We have 2 and negative 7. If you look in the denominator, if I plug in a 2, I don't get a 0 at any moment. So the denominator here, if you were to plug in a 2 and do the work for it, each of these would not be 0 at all. So 2 is a good solution. So 2 works, 2 is a good solution. And same thing for negative 7. If you were to plug in a negative 7 into the x here for the denominators, you would not get a 0 on the bottom. You would also have a good solution. So x equals 2 and x equals negative 7 are both good solutions. What would not work? Well, think about it. If you plug in a 4, you're going to get a 0 on the left fraction here. And if you plug in a negative 3, you would get a 0. So 4 or negative 3 would be options that you would have to throw out. In this case, these are not 4 or negative 3, so they're both good solutions. We have to check to make sure the denominator is not 0. One more question to go. We're going to look for the LCD. The LCD is x plus 1 times x minus 1. What do we need to do? We'll need to multiply every single term by that LCD. So I'm going to have to multiply it 3 times because there's 3 terms. So let's do this. We'll multiply the first term by the LCD. We'll multiply the second term by the LCD. And in the very right here, we'll multiply that one by that LCD. So this is going to work in our favor by getting rid of x plus 1 here on the left. And in the middle, we'll get rid of the x minus 1s. On the right, we don't have any fractions. So this results in a x minus 1 times a 2 plus, well, 1 times x plus 1. That's just going to give us an x plus 1. On the right here, we have x plus 1 times x minus 1. And so now we could distribute the 2. And this gives us 2x minus 2 plus x plus 1 equals, on the right here, I have to FOIL it out. And you should get x squared minus x plus x minus 1. Now let's collect like terms. The 2x and the x here gives me 3x. The negative 2 and the positive 1 here gives me a negative 1. And this is equal to, you'll see on the right that the negative x and the positive x cancels out. And we're just left with x squared minus 1. Let's add the 1 to both sides of the equation. And so this gives us 3x equals x squared. I can set this equal to 0 now, so let's subtract the 3x to both sides. And so we have 0 equals x squared minus 3x. Now this doesn't have three terms, so we can't use the diamond method, but we can see there is a common factor. What's the greatest common factor? Well, it's x. So I could factor out x from both of these terms. That leaves me with an x minus 3. And so we can set each of these equal to 0. And we have two possible solutions. X could be equal to 0, it's 1. Or x could be equal to a positive 3. Now you're going to have to check to make sure it doesn't cause the denominator to be 0. So let's check quickly. I know the denominator would be 0 if I had a positive 1 or a negative 1 as a solution. And since 0 and 3 are none of those, these two are good solutions. We don't have a 0 in the denominator. So 0 and 3 are good solutions.